Okay, we'll resume with the last session for today, the political and scientific misinformation. Professor Menser, if you want to test the screen sharing, it's now while I do the introduction. So we have three fantastic speakers for this session, and we'll start with Filippo Menser, which is a distinguished professor at Indiana University. Is also the director of the Observatory on social media. So the Observatory investigates how information and misinformation spread online and how you can manipulate information. And I was about to say that if you even remotely work on information diffusion problem, you probably are familiar with some of his work, such as Botometer or Hoxie, and actually the talk right before, I didn't know, but is was using Botometer, which gives me this great transition. And the title of his talk is 4 Reasons Why Social Networks Make Us Vulnerable to Misinformation. Thank you very much, Professor, for joining, and stage is yours.
Thank you guys for having me. Is the screen sharing working? Are you seeing the actual presentation and not the presenter screen?
Yeah,
it's the presenter screen.
Yeah, we are actually seeing two screens. Yeah.
You're seeing, oh, see, that's the thing that I'm always worried about. I don't know how to fix that. Let's see. Well, let me see if I can try. Okay. I'm trying again. Does this work better?
Perfect.
Okay, thanks. Thank you guys for having me. It's a pleasure. And I apologize for the clickbait title of the presentation, which is tongue-in-cheek, but I do want to tell you about research work going on in our lab, which does touch on various different reasons that social media make us vulnerable. So I'm actually going to go through a list of 4. And let me start with the story of something that happened to us a few years ago in 2014 during the run up to the midterm elections there at that time. Our lab came under attack with a disinformation campaign that started in some hyper-partisan sites and spread out to Fox News and even to Congress, where there was an official investigation. And then later went into fake news websites such as InfoWars and even Russian outlets like Sputnik and RT. And I'm not going to go into the detail of what that disinformation campaign was about. That is not important here. But we, of course, became the target of a massive amount of messages online and offline. And for a while, this was trending. And so we had an opportunity to, ironically, study the kind of disinformation campaigns that we were already studying at that time. In this particular case, where we were the target of one. So we looked at on Twitter links to various articles that were spreading, carrying various claims that were false about our research. And this is a depiction of that retweet network here. And we looked at how it fit within the landscape of political information that was on Twitter at that time. Again, this was during an election. As we know from our previous studies and also studies from many other people, you also saw in Luca's presentation earlier, there is significant polarization between conservatives and liberals, and conservatives mostly retweet other conservatives, liberal people mostly retweet other liberal people. And so in this network here, the purple nodes are the nodes in the network in the inset. Those are the networks that are spreading the disinformation campaign. And you can see that most of them are on one side. And just because this particular campaign was targeted at conservatives. And then on the left, you can see two lonely little orange dots, if you can see them on the screen. And those are the only two accounts that we could see in this visualization that were actually carrying a correction. Since, of course, this information was debunked very early on by reputable sites, including Science. And so, as you can see here, most of the people who were vulnerable to this particular misinformation were on one side, in the echo chamber on one side of this network. And then the few people who were exposed to the corrections were in a completely different part of the Twitter sphere. So basically, the people who were most vulnerable were least likely to be exposed to correction. Now, in this particular case, we see that the target was conservative accounts. And in fact, several studies, including this one in Science, have shown that during the 2016 elections, there was a significant correlation between the likelihood of sharing fake news or links to low credibility sources and conservative political partisanship. As you can see in the highlighted plot here, more conservative people were more likely to share fake news. This was based on a sample where Twitter accounts were correlated with actual voting records. We broadened that study by looking at Twitter more broadly, a much larger data set. And in this density plot, you see that there is a correlation indeed between political bias and likelihood to share misinformation. And it is stronger on the right among conservatives. So that sort of blob on the right-hand side of this plot corresponds to the finding in the Science article. But we do see that also there is a correlation on the left, although it is weaker. So it is not only conservatives that are vulnerable, it is partisan people in general. It just depends on who is the target of the misinformation campaign. And so we feel that the echo chamber structure can create vulnerability because, of course, we're more likely to be exposed to information that is targeted to us, and we're easily targeted because we all find ourselves in these echo chambers. So one of the questions that we were interested in was, what is the role of social media in fostering this kind of polarized and segregated echo chamber structure? So we explored this question with an agent-based model, which has two ingredients. One is that people can be influenced by their neighbors, and the other one is that they can unfriend people that they disagree with. So here the color represents your political stance from progressive to conservative. And at the beginning, the opinions are spread uniformly along this spectrum. And then in this model, we simulate a system where people are exposed to opinions in their social media feed, and they can either generate their own opinion, post their own opinion, or reshare what they get from their friends, even if it's indirect. And over time, because of social influence, you see that people's opinions can change a little bit. You're only going to be influenced if people have opinions that are similar to yours. And also people can unfriend, which is represented here by these dashed lines. Those are social ties that are cut and are replaced with a new connection, in this particular case, completely at random. So the key elements are that you unfriend somebody who has different opinions from you, and you're influenced by the opinions of the people who have similar opinions to yours. And these two ingredients are found on every platform. They're just part of our natural cognitive biases. And it doesn't matter whether this is Twitter or Facebook or Instagram, you're going to find that it's very easy for people to choose to select who they're friends with. And then, of course, even if you assume that influence is very, very weak, as long as it is non-zero, the model predicts that there is always the same outcome. As long as there is a little bit of influence and a little bit of unfriending, you end up with these completely segregated communities, which are very homogeneous. So people are very similar to their neighbors. So not only you lose the connections, but you also lose the heterogeneity. So that was number 4, echo chambers. I talked about 4 factors that make us vulnerable. Number 3, information overload. So when we look at a picture like this is a diffusion network for one particular piece of misinformation of fake news that went viral during the 2016 elections, which was claiming that the Clinton campaign was involved in satanic rituals. And this was one of the most viral pieces, and we study the structure of these networks, and Twitter accounts connections represent retweets in this particular case, and the color of the nodes represents the likelihood that an account is automated, a social bot, and I'll come back to that later. So a viral piece of misinformation like this one is kind of on the tail of the distribution of popularity for false claims. When we look at this distribution of popularity, we see that, not surprisingly, we have a very broad distribution with a long tail, with a heavy tail. So there's a few claims that are likely to go viral, and the majority of things, of course, do not go viral at all. But the worrisome thing here is that if you compare the distribution for false claims or claims from low credibility sources and reliable claims, for example, from fact-checking sources, these two distributions are very similar. So it's the likelihood that something goes viral seems to be almost the same, irrespective of whether this is from a reliable source or a non-reliable source. So we built a similar model to the one I was describing earlier. Again, this is an agent-based model that simulates how we access news and information in our social media feed. We reshare it, and we have some finite memory. We have some likelihood to go through our social media feed, but not too far, right? So we can model the finite attention by looking at how likely it is that we look at lots and lots of things in our feed, even going back in time. And in a model like this, no single piece of information has any value or any quality. So each meme in the simulated model is just a number. And when we observe, when we study how these simulated memes spread online, we find that there are two ingredients that are sufficient to explain this broad distribution of popularity, of virality that I talked about earlier. One is the structure of the network, okay? If the network has hubs and clustering, which are typical of social networks, then we can observe these viral dynamics. And number two is the fact that agents have limited attention. If we assume that agents have they can explore lots and lots of things in their feed before deciding what to share, then you don't see this broad distribution of popularity. But with these two ingredients, the structure of the social network and the limited attention by the agents, then you find that inevitably you find this broad distribution of popularity. So, and remember, in these models, there's no notion of quality. So that means that some stuff is going to go viral irrespective of its quality. It's inevitable. So you don't have to assume that things that go viral is because they're good or they're bad. It's just inevitable because of the mechanisms of social media. Now, what if we add another ingredient to this model, and we say that the probability that we share a meme is proportional to its quality? So now we have to assume that different memes have different qualities attached to them, and this is a model, so we can simply simulate that. We assume that quality comes from some distribution, and we assume that users can discern the quality of an object in their feed. And among the things that they look at in their feed, among the limited number of things that they pay attention to, they're going to choose something with probability proportional to its quality. So they're more likely to choose good stuff. So what do we find in this case? What we find is that if they have a lot of attention, if they can look at a lot of things, or if the information is not very high, so there aren't too many tweets going on in the system, then there is a high correlation, shown here in the darker color, between quality and popularity. So in the top left network, you see these big nodes. These indicate that high quality memes are spreading. But if the information load is higher or the attention is lower, so we are in this information overload kind of scenario, then the correlation between popularity and quality is very low, as we see in the top right network, where a lot of the nodes are very small, which means that low quality nodes are spreading. And so again, the fact that users have limited attention makes it likely that low quality information will spread. Okay, number two, engagement bias. We often hear discussions about the fact that platforms use popularity as a proxy for quality, right? If a lot of people are sharing something, there must be something good, so they might give it higher priority in the ranking feed. So we built a model to look at what would be the effect of this in a system with some distribution of quality. Okay, so here we have a parameter that is here on the x-axis of this plot, which is the probability that the platform uses popularity to select a meme to show on somebody's feed. And otherwise, they will actually use quality. So we assume that for some things, we know their quality, and for some other things, we have to estimate it from their popularity. And we also have this notion of attention that I was talking about earlier. How many things am I likely to look at in my feed? What you observe is that generally, the more the platform relies on popularity, the lower the average quality of in the system of the memes that are spreading in the entire network. Now there is a little, you can see this, that yellow stripe in the middle, which means that for a narrow range in this attention parameter, some level of popularity can increase the overall quality in the system. So this, the regime is the wisdom of the crowd, right? So this is the regime in which, in fact, if a lot of people are sharing something, that is a good signal that it is good quality. But we see that this is a very narrow regime. In general, the use of popularity is actually amplifying noise and therefore suppressing quality. So we have to keep in mind that the use of popularity itself can be a bias. And this is from the point of view of the platform, okay? Now, how about the users? So we have a game called Fakey. You can go and play with it if you want. It's a news literacy game where where we simulate a feed of news from different sources, and people have to decide whether to share it or fact check it. And what we observe is that when people are exposed to articles from low credibility sources, I should add one point. As a condition in the experiment, we show users a number, which is sort of an engagement metric. How many people have liked or shared a particular item? And this is just a random number, okay? It's part of the experiment. And so what we observe is that when people are exposed to low credibility articles, they're more likely to like or share it if they think that it has high engagement, if many other people have liked it or shared it. Likewise, they're less likely to fact check it, again, if they have the perception that there is high engagement. So high engagement here creates a vulnerability for users of social media platforms. All right, number one, manipulation. We've been studying social bots for a long time. This is one of the earliest pictures of when we discovered the earliest examples of social bots back in 2010. On the right, we have two bots that were retweeting each other, trying to promote a candidate. On the left, we have a bunch of bots that were trying to get a journalist, which is the node in the middle, to retweet a link to a fake news article. Now, this was a long time ago, 10 years ago. Fast forward to the 2016 elections, we collected a lot of data about sharing of links from low credibility sources and fact-checking sources. This is a piece of that spreading network for these different kinds of content. In purple is the low credibility content, and in orange is the fact-checking content. And again, we see that these two groups don't really talk to each other very much. Mostly the people who are sharing low credibility content, retweet each other. Now, as you move closer to the core of this network using K-core decomposition, you find that there are more bots, and this is very similar to what Luca showed earlier, right? As you go closer to the core, you get more and more bots. And what are these bots doing? One of the things that they're doing is that they're targeting influential users. So that yellow dot in the center is a bot that systematically retweeted tweets from news sources that mentioned Donald Trump, and reply to them, not retweeted them. Sorry, reply to them in red here. These are replies. The blues are the retweets. And in those replies, there was a link to a false news article claiming that 3 million people had voted in the presidential elections and they were illegal aliens. And this was a fabricated article from InfoWars. But in this way, this account was trying to capture the attention of a very influential user, in this particular case, the president. And this is an example where we found that systematically this attempt to target influential users was done by bots. We also found that the activity of the bots, when we traced it back in time, could be really noticed in the first few seconds after a fake news articles was posted. In the first 10 seconds, you could really see the role of social bots. After that, as more humans started retweeting those articles, then it was hard to see that bots were ever there, right? Because they get flooded in a sea of human retweets. So most likely these bots are coordinated with the sources. They're working together and they're retweeting something to inject it into the network in the early phases. And then of course, some bots were flooding the system. They would tweet or retweet the very same accounts hundreds or even several thousands of times for a single account. In terms of impact, we could look at retweets, for example. We see that most of the retweets in these networks were done by humans. Here on the x-axis, you have the bot score of the retweeter, and on the y-axis, you have the bot score of the original tweeter. And so the projection on the top shows you that most of the retweets came from accounts with low bot score, so mostly humans. But if you now focus on who these humans were retweeting, the projection on the left shows you that they were retweeting humans, but they were also retweeting bots. So in other words, humans do reshare misinformation that comes from bots. And again, this is very similar result from the one from Luca earlier. Ours is, yeah, so very similar finding. And if we look at
I'm sorry,
recent...
Filippo, we're running really out of schedule. So if you could conclude.
I will try. This is just to show that very similar patterns are happening right now with misinformation about the COVID virus. And just to give me a minute to just say that we have a bunch of tools that are publicly available to anybody who wants to try them at our observatory's website. You mentioned Botometer and Hoaxy. We now are focusing on coordinated influence. For example, cases where an account itself does not seem suspicious, but then we find that it is very, very suspiciously similar to other accounts. And this could be because they share handles, or in the case of coronavirus, they retweet the same accounts. And I'm gonna skip other examples, but we find that it is possible to detect these kind of coordinated behaviors. And we have a new tool that we invite everybody to play with. It's called BotSlayer. And the idea is to make it easier to detect in real time, basically narratives that are being pushed by inauthentic accounts or coordinated accounts. Like in the picture on the bottom right here, there was an attack that was carried out by a bunch of Russian bots. So you asked to mention some of the interesting open questions. And for me, the most important open questions are about impact. Can we quantify whether opinions are changed? There was a question earlier. I think that's still an open challenge. Can we measure whether there is vote suppression that happens? Can we measure whether policies are affected? Can we measure even deaths? Are they affected by misinformation about coronavirus? These are important open questions. So I'll close here, and I want to say thanks to all my wonderful students and colleagues who are authors of this work. Thank you, guys.